Hey everyone, some other people might join you, but we will start. We will test Ozone. A few words about myself. I joined Ozone 2 years ago as an intern, and during the last half a year, I've been testing performance. Let's talk about what performance is. Performance, you know what it is, but it's quite a wide notion. So, if we are to discuss computer performance, is about benchmarks that test the component power, computing power. If we look at performance as a website, then perhaps we would think about certain quality units like the maximum size of image, number of requests per unit of time, or if we ask what is more important for a user, then intuitively we might say that metrics on the right side, which is how long it takes for the page to load and how smooth the scroll is. So what we picked is performance that can be viewed. This shows how much comfort there is in communication with your product. If it's important for user, it's important for you. So we need to know to test it. But even if we understand it, sometimes there could be abstract business asking why spend resources on improvement. The user can go through this business scenario. I prepared for this, and I looked for details about business metrics. As when performance goes down, the business metrics also go down. But the latest research done just 2 or 3 years ago, the speed of page download were slowed down by 1 or several seconds. And Ozone did the research, said when the page slowed by 0.1 second, the metrics demand go down. When it's 0.5, all the user metrics go down. The client no longer starts using the app less and less, and then will probably walk away from this app. Now, to test metrics, let's talk about what they consist of. This is a scheme of how page download looks like if you are to separate it into components. You click this or that element, and then you initiate the page. This is a client-server application, therefore you will see how long it takes, DNS time, which we need addresses to be transformed into IP address, then the TCP time, which is the time for low-level connect, and TLS, the encrypted connection. Once there is a connection, then you look at the request time, also the server time, and the response time, how long it takes to get an answer. Usually we talk about metrics time to first and then time to last, which is beginning of response, end of response, to first and second, a useful byte of information. Then we have decoding time, which is how long the app needs to transform the response, which is a JSON file, transform into view models. Once we have view models, they have to be showed on the screen, and then they must look good enough to be well interacted with. Then the page is fully downloaded. Until then, this is still total download time. Now let's talk about the smooth scroll. This scroll is pretty slow. So this scroll is pretty slow, and this is an old version of this app. It shouldn't happen. Just tell us. We'll do debugging. The smooth scroll metrics is a bit more complicated. Let's talk about what delay is and how we can measure the delay. We'll have to understand how animation works in the screen and how long, if the screen updates too often, it's not good for the developers. On top, we have how smooth animation can work, 16 milliseconds, and next still and next still. So why 16 milliseconds? This is time that the screen needs to show the next still. We have this formula. You see this formula on the screen. And then the refresh rate 60 Hertz in most applications. That's the frequency. And then we go down to each time. So we see here that the first is still is depicted, then 16 milliseconds, but the request for the still to be processed is not complete. So it took 20 milliseconds instead of 16 milliseconds. So what we're ready to depict the still, but since the refresh rate is this much, well, this is where we can depict it. Therefore, the delay time or the hitch time is the differential between actual time needed for depiction and also the still required by the system, which is 16 milliseconds. So the delay time will be 16 milliseconds. This is how we can understand the time that the scroll was delayed by, but we don't understand how smooth the scroll is. We'll have to introduce the hitch rate ratio. It will be equal to ratio of total delay to total scroll. I think scroll is now well understood. Let's go on and understand what issues we had, why we decided to test performance. Let's talk about the release process in Ozone. That's a good presentation of my producer, and I'll provide the links. So weekly releases. Each week you get 2 releases, and up 10 to 20 bigger tasks usually make it to those releases. And this can affect performance, and you have to trace that. Now let's see how we test performance before. That's an example. So you scroll the list and you want to make sure that it's smooth enough. That was quite difficult to trace all the bugs, to see all the bugs, unless this was a case of a critical crash. So we were not happy about it. We understood that performance was broken only because the application was distributed among users, and that's when we received bad metrics. So the performance metrics go to ClickHouse, and then here you can see Charles screenshot. They also didn't do mobile tested. This is a main sniffer, main tool for mobile tester. This helps see which data comes in and comes through backend. Those are events for analytics. But let's remember that I call pages screen applications. This is a web term, but We call it screen page. So for a page, this is a key event. We have layout time and decoding time here, and many other metrics that didn't make it to the screenshot. Why this is for developers, for performance to be tested, we needed a unique identifier, so we could distinguish test metrics from user metrics. And hash commit was an example. And now this is one problem less. To test performance, we had to tune the performance farm for real devices. Mac Minis were those that we chose. iPhone 11, XR, Samsung A52, Xiaomi, Redmi. So 8 devices for each host. We picked them based on user analytics and average. It's also based on average computing power. So we picked the most critical pages, the after tests that are quite simple. So they load a page, and then the metrics are delivered. Now, this is a screenshot from the pipeline. This is where the after tests are run. This is the Samsung and Xiaomi. This one is analytics in the next. And then once the tests are through, and this is where the metrics are collected, and this is where we analyze them. Then we generate a comment, and a comment goes to the tested ticket. That's how it looked like in the beginning. And MVP, we had 6 basic pages automatically generated for each page. We checked the speed for each page, and we compared it with the threshold, which was manually set when we made comparison in the job analytics. Then if this file will be changed by a red cross if this meaning goes beyond this threshold. So this would be an alert for a tester. Maybe he would have to contact the developer. We, at this stage, did not sift the critical changes. We could identify those before the release went to a user, but the disadvantage was lack of visualization, lack of dynamics in the metrics, and lack of information, lack of awareness, and we had to work manually to set the thresholds. We used the graphic solution. This is layout time and decoding time. We send it through Prometheus, and then we pick them from there and can pick the page platform and include annotations for iOS and Android. This is this vertical broken line. So we click on this one. On this summary, we could see the task and the metrics and also the unique hash commit of the build. There's a spoiler available. In the legend, you can see develop, epic, and release. So we built in not just in the pipeline, but for each developer built-ins. That's how we run those after tests, and during the release, collect the analytics and send it to Graphon. This is how the current release looks like. The report is larger. We added some pages, and then hit rate is another change. We needed to run new after test. Not do they open the test page, they'll also scroll it. And then for comparison, we have not just total time, but layout time and decoding time.
They are not compared manually with specified value. They are compared with a we still have some events left, and you can go to job, you can go to Grafana and get a detailed report. So what can you do with these beautiful reports? We have charts, and it needs to be integrated into the performance testing process. Early on, we did not test it, and we started this process from scratch. It's part of life cycle for Epic. Pretty orthodox and standard, but let's talk it through. Under development, all subtasks in Epic needs to be designed and tested, and only then a task transforms into final QA stage, where a responsible tester verifies the key functions, writes test cases if when needed, writes auto tests, while launching automatically all UI tests, this full regression. And then at the real device farm, performance analytics begins. In the event, no non-conformities found with the performance, then everything is okay. But if performance is too high or is outside of the specified range, then we enter a bug, a tester fixes that bug, and then Epic goes into final QA and the cycle repeats itself. What challenges have we faced when launching farms and tests? Most of the UI tests are launched using simulators and emulators. When it comes to performance, we didn't have such an opportunity. For iOS environments, you need to be granted authorization from the developer. As for Android, problems were mostly related to unstable Wi-Fi, or they could burn out while connected to the farm. Also, there were issues with system alerts. Automatically, those elements could not be swiped. So often in the work chat, we requested co-workers in office to receive an alert, to reboot the system, to check Wi-Fi, and so on. How did we troubleshoot and minimize the problems? We set up STF server. It's an open source project, and it's hosted. It's launched on the host where Android devices are connected. From any point in the corporation, we can get connected and pull up a screen showing all connected devices with their names, models, connection status, and even such minute parameters as temperature of battery and battery charge. So we could reload it by Wi-Fi automatically. If we go deeper, this is how a device screen looks. We can use a mouse to control some elements. We can swipe, tap, and manipulate in other ways. To give you more details, you can install hardware and software package. There is lockhead, screenshots. You can press system buttons, reload the device. Most of the issues we encountered with Android devices has gone a long way to help us here. There are multiple tabs here. We haven't tested all of them. It helped us not only in the performance. Let's say you're testing a ticket, a bug is reproduced, you put it in, you give it to a tester, the tester says the bug does not reproduce on his or her emulators. Locally, you can pull up STF and then a developer would connect to your device and remotely fix the bug. It gives a full access to all the devices. So, for the summary, what you need to do is connect and set up farms, writing UI autotests, writing metric comparison functions. Then you need to have integration in development pipeline, visualization of metrics in Grafana, building work processes, and remote access to devices as a bonus. It's worth noting that this is a living project. It needs to be supported and maintained. It's not like you set it up once and it goes to live on its own. We cannot have that luxury. Presently, there are some changes made to this project, but I guess we will be able to elaborate on that in future talks. Now, this final slide comes as a bonus. It's not about performance, but about enhancements of performance perception. On the first screenshot, we see a famous loader, a useful thing that you need adding if you have a long transition between screens, a long loading time. This is a reminder that the request hasn't been neglected and soon the result will be shown. And it also shades or hides other interface elements so that we, as users, are not tempted to push them or to go somewhere else. Then another screenshot covering 1.5 size of the mobile phone, so it goes beyond the margin. It provides a list, so you can use scroll. Users are likely to want to see everything below the screen, so in order to keep users from waiting until they get to the bottom of the page, we load this as a cache picture, cache image, and when a user scrolls down, what he or she sees is not a placeholder, but the well-drawn elements. The size of loadable content, the resources needed for loading additionally, all of that depends on the power of the device. For smaller devices, it could be in one device. For more powerful ones, 2 or 3. A recent enhancement available on Android is a list of items. All images are loaded from a container, and on this slide we don't need that big an image, and once we open the product card, it gets us to a screen where a larger resolution image is necessary. But what we do to help users is elongate this picture for the time being, and once it's loaded, a user may be able for a second to see a blurred picture, but it's much better than watching a placeholder for a couple of seconds. I guess that's all from my side. I guess I've been rushing it a little. On the other hand, it gives us more time to discuss your questions and comments. Thank you. Are there any questions?
Hi, thanks for the presentation. I would like to ask about, do you think performance tests
Спасибо за презентацию.
NRs and memory leaks
Используете ли вы в своих проектах NRs, Memory Links,
for tracking memory leaks and getting INR?
для отслеживания Memory Leaks? Do you have any tests for memory leaks and not responding applications? No, we don't have auto test for memory leaks. We have flow processing to capture memory leaks, and there is a flow to fix those bugs. It's not something that could be called automatic. It's done manually. INR is sent to Firebase database, and then it's worked in as tickets. Thank you. Thank you very much for your talk. My question is, how many launches of pages do you need to understand that this time for performance is something that is going to satisfy you? The number of launches is set in jobs. At the moment it's about 50 per page. For hit rate it's different, and on the average, because of 50 launches per platform, we average based on quintile and compare it with the release value. You mentioned that you use non-filler charts. Can you do the same with filler? We just don't use it in our performance testing charts. It was an example of how an event looks. Job analytic data is taken from ClickHouse, meaning Charles is not used here, so any sniffer will work. Thank you for your presentation. I wanted to ask you, but I forgot. Oh, my second question is, why can't it be executed in emulators and simulators? Most of the auto tests are done using simulators and emulators, but for performance it will not be valid enough. The powerfulness of emulators depends on how strong and productive devices are. Therefore, it will not correlate. You skipped the tool topic. Do you use native tools? ADB, for example? Yes, I did skip it. I thought that it wasn't that important. We use Appium and Selenium Grid and Driver again. Those are not native testing tools. But it doesn't really matter what we use to run our autotest through. It's important that those events are finally generated. So you just pull out those events. Our events are assembled, are built. We did not invent them. They had been pre-built. All we needed to do was to do some UI action on devices that would trigger sending those events. Hi, thank you for your presentation. Couple of questions. Number one, I came in late. I may have missed it. My question is, what environment is your app set up for? What backend is used for this test? Is it production or stage environment? Yes, we use production environment, like for most UI tests. Predominantly, we test everything on production environment. Okay, second question. I'll have to tweak it a little. Have you given any consideration to launching performance tests in the backend and test on devices, and then compare applications with increasing pressure? Because when main backend is stalling, it creates slower rates, and an application may behave completely differently compared to how it behaves in the morning or in the evening. Ozone is a pretty big team, and the roles and responsibilities are clearly divided. Mobile handling team should be responsible for this kind of testing, and if it's backend, I think it's backend guys handling the server who should be running those pressure tests or load tests. In the hierarchy that we're using, I don't think it's feasible. And my final question, I again may have missed something. There is device temperature metrics. How well do you track it? Do you track it at all? Let's say we launch Gaussian Impact in real devices, then we switch to our app or open a few apps on the bounce from other developers that are populous in a country of ozone use, by emulating a more or less realistic mode of operation. I mean, there could be games, online shops, multiple tabs. How will that work? I'm all out of questions. Thank you. I showed you a slide with device temperature. It's just a feature of the STF server. It's available on Android only. STF supports only Android devices, and we did not track temperature. It's not traceable metric for us. I guess we need to give it more thought. And about simultaneous launch of other apps, the infrastructure will find it hard to handle. Other apps will somehow need to be supported or run in the background. You can't pull this off with auto testing alone. Thank you for your talk. How did you manage app performance before you applied your system? We did not measure performance early on. We analyzed it, or our analyst reviewed it when a release was already distributed to users, and we checked the layout time in the log data. And based on that, we made our conclusions. Thank you for your presentation. Do you compare performance of your app with performances of your competitors? Yes. There is a project comparing competition performance. We are not able to set up automation the way it is set up for competition. So the way we do it is we make a recording of a video of time. I mean, we're recording time of one page or another page, and then we have microserver where all the data is supplied to compare metrics and total time. So we basically look at whether a page stopped refreshing, meaning it has been loaded completely. All right. Since there are no further questions, let the best question asker be gifted. Oh, there is also a present from Ozon. Yeah, neat bags